Hello guys, now for another lesson. We are still doing 5.2. It's broken into two parts, so this is part 2, and this is called synthetic division. Before I do this, I do want to review from yesterday. I know that's a challenging subject. I hope you did okay. Let's review this process. So this is polynomial long division, and you start in this place and you ask yourself, what can you multiply p by to make it equal 3p to the third power? So we're going to need to multiply this by 3p squared. So when you multiply here, 3p squared times p is 3p to the third power. And that's what makes these match. And that's the critical step there when you're doing this process. Now you have to distribute to here, 3 times negative 9, so negative 27p squared. Draw a line, put these in parentheses and minus. This cancels out. Distribute here, you get plus negative 26 plus 27 is 1p squared. Bring the next term down, minus 12p. Now repeat the process. What can you multiply p by to make it p squared? And that's just going to be a plus 1p. Distribute here, that's p squared. Distribute here, minus 9p. Draw a line, put parentheses and minus. P squared minus p squared cancels. When you distribute here, it turns to plus. Negative 12p plus 9 is negative 3p. Bring down the plus 30 and repeat the process yet again. What can you multiply p by to make it equal negative 3p? That's going to take a negative 3. Distribute. Negative 3 times p, negative 3p. Negative 3 times negative 9 is plus 27. Draw a line. Parentheses, minus. When you minus minus, it turns to plus, and those cancel. Put a minus here. 30 minus 27 is 3. So your final answer is 3p squared plus p minus 3 plus 3 over, and then the original divisor, p minus 9. So that's the answer. That's what we learned how to do yesterday. Today, I'm going to show you something called synthetic division. Synthetic division achieves the same thing with less work and difficulty. As long as you understand how to do it, it's less work, which is a good thing. So I'm going to just use examples to go through this. There's no other notes here, just it says see below. Now, I'm going to redo this same exact problem. I believe I have it set up, yep, right here. And I'm going to use it in this process called synthetic division. So instead of putting a divide bar like that, you put an upside down bar, and it's got to be twice as big. It's got to be able to fit 2 rows of numbers here. Okay, so the top row of numbers, you're just going to take, basically you're removing the variables. You just put the numbers down. So that's 3, minus 26, minus 12, and positive 30. Out here, you put the divisor, but instead of putting p minus 9, you put, well, it's what you would get if you set this equal to 0. Now, you don't really have to know this, or you don't really have to do this, because what it ends up being is just the opposite of that number. So you're going to put a 9 there, right? There's a 9. So I'm just going to erase this. It's going to clutter up all the work. For now, just think it's the opposite of this number. Okay. So here's the process. You always start by bringing the first number down, right there, 3. Okay, that never changes. Always bring it down and write it there. Then you multiply this number times that number. 9 times 3 is 27. Write the answer here. Now, just like you're doing column arithmetic, combine those together. Negative 26, positive 27. If you combine those, you get positive 1. And bring that down. Now we're going to repeat the process. Multiply these together. 9 times 1 is positive 9. Write it here. Combine negative 12 and positive 9. Negative 12, positive 9 is negative 3. Write it there. Repeat the process. Multiply. 9 times negative 3 is negative 27. Write it here. Combine 30 and negative 27, and you get 3. Okay, all these extra arrows and writing the word multiply and blah, 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 I'm not going to do that in every problem. I'm just doing it on this first problem, kind of like, notes. In fact, I'm going to erase them now, so get a good look at this. You can always back up if you want to rewatch this. the point is, after you bring the first number down, right, I brought this 3 down right here, it's the same thing over and over. Multiply, combine, multiply, combine, multiply, combine. So you're only doing really 2 operations. Well, combine could be adding or subtracting, so 3 operations. Now, what is this result? 3, 1, negative 3, 3. Well, if I look at the answer I got up here, do you see how it has 3, 1, negative 3, 3? It's those same exact numbers. Now we need to make an observation. The answer is 1 degree less than the original dividend. So it started out with 3p to the 3rd power, now it's to the 2nd power. And that always happens. I don't know if you noticed that on yesterday's assignment, but that always happens when you divide by a binomial. So we know that our answer has to be 1 degree less than 3. So that means all you got to do is write in a p squared here, plus p here. You already got your negative there, so you don't need to put in a plus or a minus. And then plus 3 over the original divisor, p minus 9. And all of a sudden, you've got your answer. And generally speaking, once you learn this process, once you get it down, it's a lot quicker and easier than doing that mess. Let me scroll down and check just to make sure. And yeah, there it is. All right, so let's do this again, see if we get it. So how do you set it up? So an upside down divide bracket, make it a little oversized. Take the numbers only, so negative 4, 35, 15, negative 58, and 34. And then the opposite of that number, so positive 9. Got it? Always start by bringing this down, and then multiply. 9 times negative 4 is negative 36. Combine. 35 and negative 36 is negative 1. Multiply. 9 times negative 1 is negative 9. Combine. 15 and negative 9 is 6. Multiply. 9 times 6 is 54. Combine. Negative 58 plus 54, negative 4. Multiply. 9 times negative 4 is negative 36. Combine. 4, negative 36, negative 2. Get all these goofy arrows out of the way. And how do we sort of make our final answer? Well, if the problem started with p to the 3rd, the answer starts with, the problem started with p to the 4th, the answer is going to start with p to the 3rd. And then count down. So it's p to the 3rd, p to the 2nd, plus, I got to put a plus sign in there, p, minus 4 is the constant, and then that last number is always your remainder, so that goes over p minus 9. So this is our answer. Let's check number 4. And there it is. And when you get good at these, you can just crank out the answer lickety-split. I mean, it's so much better than doing that whole algorithm. All right, let's try it again. Practice makes perfect. Also, number 6 is a little bit of a trick question. Notice that we got 4th power, 3rd power, 2nd power. There is no 1st power, and then it skips to the constant term. So when we set this up, it's going to be 2, negative 9, negative 56, 0, 5. That came up yesterday, how you have to put a 0 term in. You also have to put a 0 term when you do this method. And then again, the divisor is going to be 8. It's the opposite of that number. All right, bring this down, multiply, combine, multiply, combine, multiply, combine, multiply, combine. So I didn't draw all the little arrows this time. Hope that wasn't a problem for you. The problem started with 2x to the 4th. That means our answer is going to start with 2x to the 3rd. Plus, since that 7 is positive, plus 7x to the 2nd, plus 0x plus 0. The 5, the remainder is positive, so I put plus 5 over x minus 8. And that is our answer, but just like yesterday, you usually don't put the 0 terms in your final answer, so plus 7x squared, and then you can just write plus 5 over x minus 8. And that ought to be all there is to number 6. There it is. Get it in the short-term memory. Yep, there it is. Okay, so your first 3 problems will be just like these 3. Make sure you put in a 0 term where needed, but the process is pretty simple. Now, the next page is going to be a little more complicated because our divisor has a coefficient, and that does change things a little bit. What I told you before, just take the opposite of this number, it's not going to work. In this case, you actually do have to set the divisor equal to 0 and solve it. Divide by 9. You get p equals -5/9. So when we do this division problem, I do have to use -5/9 as my divisor. So that adds an extra wrinkle into this. When you have a lead coefficient on your divisor, yeah, instead of being the opposite of this number, it's the opposite of this number over that number, fraction. And then you put these numbers down. And you might not like the idea of having a fraction here. Honestly, they usually work out, and you can use a calculator to help you if you need to. Okay, so it starts the same, put a 9 here. Now we need to multiply -5/9 times 9. Well, when you multiply ninths times 9, the 9's cancel, and you just get, in this case, -5. So that's pretty easy. Grab a calculator and type in -5/9 times 9 if you need to. Combine these, -22 minus 5, that's -27. Now repeat the process. Multiply here. Negative times negative is positive. What's 5/9 times 27? You know, if you couldn't do fractions, the 9 goes into 27 3 times. 5 times 3 is +15, so there you go. If you can't do fractions like that, I'm going to say it again. I'll say it over and over. Use a calculator. Don't sweat it. Don't let it be something that stresses you out. All right, -42 plus 15 is what? 20. Oh, it's also 27. This time, yeah, still -27. Multiply -5/9 times -27. The negatives cancel. Works out to be 15 again. -60 plus 15 is -45. Multiply here. Negative times negative is positive. 9 goes into 45 5 times. 5 times 5 is 25. So I'm working the fractions out in my head. But notice they're all ending up being whole numbers. Use a calculator. It shouldn't be a problem. -34 plus 25, when I add that up, I get, what is that, -11. And so from here, I go to put my answer together. And I'm going to warn you, this might not work out as nicely as we want. But anyway, if that was p to the 4th, our answer has to be p to the 3rd. So 9p to the 3rd minus 27p to the 2nd minus 27p minus 45 minus 11 over the original divisor, which was 9p plus 5. Now, when I go to check this, what do you see? Does this answer match what I just got? Oh, well, first of all, no, it doesn't. One, because I made a mistake. Duh, why do I do this? -34 plus 25 is not 11, it's 9. Jeez Louise. So that 11 was supposed to be a 9. Okay, and that's not even the issue. The issue is these numbers. They do not match those numbers. Why not? Oh gosh, this can't be. Well, here's the deal. The lead coefficient does really screw things up. So I had to make this fraction to do this whole process. But now, because of that 9, all of these numbers are 9 times bigger than they're supposed to be. If you look at the actual answer, that's 1, -3, -3, -5. The remainder is fine, assuming you don't have an 11 like a moron. But anyway, the other numbers here are all 9 times bigger than they're supposed to be. So when you have a lead coefficient, not only are you supposed to use a fraction, then you're supposed to divide everything by 9 to make it finally work. And you end up with 1p cubed minus 3p squared minus 3p minus 5 minus 9 over 9p plus 5. Okay, so we've got another one. It's gonna, it's got that lead coefficient. We're just gonna have to deal with it. So if I set up my problem, 4m to the 4th plus, oh no, dumb. 4, 24, 20, -4. And then if we set this equal to 0, 4m equals -4, divide by 4, we get a -1. Okay, bring this down, multiply it. combine it, multiply it, combine it, multiply it, combine it. All right, so I get 4m to the third power, right? 1 less than that, plus 20m squared plus 0m. Oh no, nuts. Oh, I screwed this one up badly, badly, badly. See how that's a second power? And then it jumps down to a constant? Oh. Well, oops. I needed a 0 term in there. Good grief. I just want to stop the video and start over, but no, I will let you see my humiliation and my mistake. So all this works out the same, but I have this placeholder term because the whole standard form thing, it skips. Yeah. So 0, bring that down. Wait, 0 times, oh man. Now I'm all flustered, I can't even do simple things. -1 times 0 is 0. It really didn't change that much. I probably will still get the right answer. Okay, so that was p to the fourth, or m to the fourth. So this is 4m to the third plus 20m to the second plus 0m plus 0 minus 4 over 4m plus 4. And let me look at the answer right here. Okay, so what's going on? Well, again, all of these answers are 4 times bigger than they're supposed to be, right? Because of that 4. So we've got to divide these by 4. So we get 1m to the third. 20 divided by 4 is 5. Gosh, I'm just messing everything up. And then the 0 terms, you can just do away with. They're gone. But look at the remainder, 4 over 4m plus 4. That remainder can also reduce. You can reduce this all by 4. And you end up with 1 over 1m plus 1. And man, number 10 is about the worst possible problem you can have. I mean, this is bad as it gets. So it was missing a term, which you need to put a 0 in as a placeholder, which I messed up. Had to redo it. Your answer is 4 times bigger than it's supposed to be because of the lead coefficient of 4. And the remainder just happened to be reducible as well, which has never happened. Like here, we couldn't reduce 9, 9, and 5. You can't just reduce the 9 and 9. You got to reduce all the terms to reduce a complicated fraction like that. But anyway, we got there. There's the answer. Okay, number 12 is supposed to be the tricky one. Do you see how everything's written out of order? Nothing is correct. So before I do anything, I'm going to make this k to the third plus 11k squared plus 14k minus 80 divided by k plus 8. So now that it's all rearranged, I can do the synthetic division. It shouldn't be too big of a problem. 1, 11, 14, negative 80. And there's no lead coefficient, which makes this a little easier. I can just put a negative 8 here and then do the process. Bring down a 1, multiply. Combine those, you get 3, multiply. Combine those, you get what? Negative 10. Multiply, you get 80. Negative 8 and 80 is 72. That's a big number. Okay. The problem started with k to the third power, so our answer is going to be 1k to the second power. And then positive 3 is plus 3k minus 10 plus 72 over the original divisor, k plus 8. And that, boy, if that's not the right answer, I am going to quit. Oh, man, I shouldn't make threats I can't keep. I'm not going to quit. I got to support my family. I need health insurance. What the heck? There's no remainder. It's supposed to be... Oh. Duh. Okay. Simple, easy mistake. Maybe you saw me make it. Hopefully. Right here, that's an 80, not an 8. Right? That's an 80. And what's negative 80 plus 80? Duh. 0. And with a 0 there means there's no remainder. So, all right, here's what I want you to do. In the comments, post a vote. Should I quit my job or not? Is this a career-ending mistake? Otherwise, good luck with this work. Hopefully you get it down. The first page should be much easier. Make sure you totally got the first page down before you go to the second page. The second page, that lead coefficient stuff, makes it a little more complicated. And then number 11, remember to rewrite the original problem in order before you start it out. Otherwise, good luck. Contact me if you have any questions.